Good morning, dear students. How are you all? Very good. Yeah, I'm also fine. So, before entering into our today's class, let me tell you a story. My one experience. Are you ready? Yes, that's it, my child. Today, when I came to school early morning, on my way, I saw a farmer who is sprinkling something into his field. A farmer who is sprinkling something to his field. I was very curious about to know what he is doing and for what purpose he is doing. Please tell me, if you are in my place, what will you do? Yes, of course, very good, Anirudh. Just like as how Anirudh will behave, the same way I went to that farmer and I asked him, what are you doing? What was that you are sprinkling into this field? He replied me that he was sprinkled a chemical named slaked lime. He was sprinkling slaked lime, which is a chemical, as you all know. Am I right? Yes, of course. So, I asked him again that, what you are sprinkling this slaked lime into the field? So what will be his answer? Can any one of you guess what may be the reason or for what purpose that farmer sprinkled that slaked lime into his field? Okay, before getting into that answer, where is our Ajay? Yeah, okay, Ajay. I think Ajay's father is a farmer. Am I right? Yes, that's pretty good. Okay, Ajay, please tell me or tell to us that, have you ever witnessed your father behaving in the same way as I saw that farmer? Okay, very good. So your father also sprinkled something into the field. Am I right? Yes, of course. So have you ever asked him what was he doing and for what purpose he is doing? Okay, then can you please share those experiences with us? Okay, very good. So dear students, as how Ajay has explained his experience, in that same way, the farmer told me that the soil in his field is acidic in nature. He told me that the soil in his field is acidic in nature. We all know that what is meant by an acid and what is meant by an alkali. In our previous class, we learned about these topics. Am I right? Yes, of course. So he continued. In order to decrease the acidity of that soil, he used that slaked lime. And we know that slaked lime is, tell me, is an alkali. Slaked lime is an alkali. Very good, Ravi. So, we studied about neutralization reaction in our previous class. So, what happens in a pre-neutralization reaction? Can anyone please explain? Yeah, okay. Please go ahead, Lamia. Yes, very good, super. In a neutralization reaction, an acid and an alkali reacts with each other and they cancel the properties of one another. They mutually cancel one another's properties and thereby produces salt and water. Am I right? Yes. As an example, in our last class, we looked into the common neutralization reaction between HCl means yes hydrochloric acid and NaOH means our sodium hydroxide. So they two react with each other or combine with each other and forms NaCl. What is meant by NaCl? Yes, NaCl means sodium chloride along with sodium chloride along with water. So an acid reacts with an alkali and produces salt and water. So this is the general reaction for a neutralization process. Okay. So an acid reacts with an alkali and produces salt and water. So here what happened? The alkali neutralized the properties of the acid and vice versa. That is, the acid also neutralized the property of this alkali. In the same way, when the farmer sprinkled that slaked lime into the field, since slaked lime is an alkali and as he mentioned that the soil is acidic in nature, they both cancel their properties to an extent. Thereby, the acidic nature of the soil gets decreased, and for what purpose he did so? In order to make his crop grow easily in that field. Each and every crop needs their own atmosphere to grow. So some crops need acidic soil in order to grow up, whereas some others need alkaline soils or alkaline condition. So in that case, that farmer needs a soil which have much lower acidic nature. That's why he decreased the acidic nature of his soil by using slaked lime. Is it clear for all of you? Yes. Have you any doubt? If you have any doubt, please ask me. Okay. Then I'm going to separate you all into 5 groups. Okay. So just start counting from 1 to 5. Okay. Are you ready? Then okay. Amal, please start the counting. Okay. So those who got number 1 belongs to first group, with number 2 second group, and number 3 the third group, number 4 the fourth group, and number 5 to the fifth group. So just rearrange your position. Quick. Yeah, okay. So shall we start our today's program? Are you ready? Are you interested? So shall we start? Then here we go to our today's class. So today we are going to discuss about how that farmer knew that his soil is acidic in nature. He used slaked lime in order to decrease the acidic nature of his soil. Am I right? Yes. Then how did he came to know that his soil is acidic in nature? Yes. Today we are going to discuss about that topic. How to identify or how to finalize whether a given compound or a given solution is acidic or basic or neutral in nature. So today we are going to discuss about all these criteria. So first of all, I am giving you some activity cards. So here I have 5 activity cards with myself. So I am giving this to all of you, to all these 5 groups, and you have a task in this activity card. So you have to complete that task, and I am giving you just 3 minutes. So within that 3 minutes, you have to go through the task, you have to discuss within your group, and you have to complete that task. Okay, are you ready? Ready? Then here we go. Yeah, okay, time is up. Okay. Hey, don't no. Just concentrate on your group only. Okay. Don't get involved in at this point. Okay. Okay. So please take a seat. So group number 3. Where is group number 3? Here. So what was that task? Yes, of course. There are some chemicals in your activity cards and you have to classify them according to your knowledge. Am I right? So according to your knowledge, you have to classify those chemicals. So that's your choice on what basis, on what criteria you have to classify them. So shall we write the answers? Okay. Then group 3. Okay, you can proceed. So, what are the chemicals? Yes, of course. There is hydrochloric acid and we have sulfuric acid and we have soda water. Okay, so these three are acids as per your group. Am I right? Okay, so they said that these three belongs to the acid category. Okay, thank you. Please take a seat. Group number 2. Okay, please. Okay, sodium hydroxide. Sodium hydroxide then. Okay, calcium hydroxide. Calcium hydroxide. Basic category. Okay, so that. Basic category. Okay, according to that. Where is group number 5? Yes, here. Okay, as per your group. Okay, sodium chloride. Sodium chloride, right? Potassium chloride. Okay, they belongs to the salt category. Salts category. Okay. So, what about group number 4 and 1? Okay, group number 4. Please tell me whether all these classifications are true or false. Is there any mistake? No. So according to your group, there is no mistake in these classifications. So you two have done the same thing. Okay, where is group number 1? Okay, please tell me. Arya, you can proceed. So whether all these classifications are safe or right or wrong. Okay, so you two have done the same thing. Okay, then let us give a big applause to all of you, to each and one of you. You have done a very good job. Your predictions are 100% correct. You have done it clearly. No doubt you have done all these classifications to an accurate level, which means your findings are 100% true. So I gave you 7 compounds, 7 different compounds, of which 3 belongs to the acid category. Who are them? Hydrochloric acid. Yes, come with me. Hydrochloric acid, sulfuric acid and soda water. Then in the basic category we have sodium hydroxide, calcium hydroxide and the remaining 2 members, namely sodium chloride and potassium chloride, they belongs to this salt category. So I'm sure that you are all very well thorough about these 3 topics, namely acids, alkalis or the bases and the salt. Okay. Okay. Roshni, where is Roshni? Yeah, here. Roshni, please tell me what is mean by an acid. What is mean by an acid? Yes, very good. Give her a big applause. Very good, Roshni. Acids are those substances which can liberate H plus ions while dissolving in water. So, acids are substances which can liberate, or in other terms, which can, yes, very good, which can increase the concentration of H plus ions while dissolving in water. Is it right? Yes. So acids are those substances which can liberate or which can increase the concentration of H plus ions. The concentration of H plus ions while dissolving in water. While dissolving in water. So this is the definition for an acid. And what about the base? In the same way, bases are those substances which can increase the concentration of, yes, tell me the concentration of, very good, hydroxyl ions. The concentration of hydroxyl ions means OH minus ions, the hydroxyl ions while dissolving in water. Okay, so you just take your notebook and write the definition of a base. So here I have wrote the definition of an acid. In the same way, you have to write the definition for a base also. You got it? Okay, then go. So, and acids are those substances which can increase the concentration of H plus ions, whereas the bases will increase the concentration of OH minus ions. Okay, now you have been provided with 3 test tubes. Am I right? So I have given each group 3 test tubes. Okay, so I have filled those test tubes with some chemicals, and the names of those chemicals are indicated in the test tube itself. So group number 1, please write what are the chemicals that I have provided to you. Yes, very good. In the first test tube, you have vinegar. And in the second test tube, you have sodium hydroxide. And in the third test tube, you have sodium chloride. So, these 3 chemicals are provided to you in 3 different test tubes. Okay, so in the first test tube, you have vinegar. And in the second test tube, you have sodium hydroxide. And in the third test tube, you have sodium chloride. And I think something else too I have provided to you. What was that? Can anyone? Yes, of course. You have 2 more purples with yourself. You got it? Yes. What are the colors of these purples? Yes, of course. One is blue in color and another one is red in color. So these 2 purples are known as litmus purples. These 2 purples are known as litmus purples. Litmus purples. So what are the colors of litmus purples? You have a blue colored litmus paper and a red colored litmus paper. So litmus papers are of 2 colors. One is of blue and another one is of red. Very good. So now, can anyone please stand up? Any group? Anyone, please? Yeah, okay, Sneha. Very good. So, Sneha, you have one activity to perform in front of all of us. Okay, take any one test tube that I have given you. Okay, which one is that? Sodium hydroxide. Okay, very good. So, Sneha has selected sodium hydroxide. Sneha has selected sodium hydroxide. Now, take that blue litmus paper. Okay, now dip that blue litmus paper into the sodium hydroxide solution. Everyone, just concentrate on her experiment. Okay, what happened? Nothing happened. Is there any color change on your blue colored litmus paper? No. Okay. So just note down your observation that while dipping the blue colored litmus paper into the sodium hydroxide solution, no color change occurs. Okay, nothing happened to that litmus paper. Okay, Sneha. now dip that red litmus paper into the same solution. What happened? Yes, that's it, my girl. The color changed. Yes. So what was the change in color? Yes, of course. That red color of the litmus paper changed into blue color. Is it any magic? I have done nothing, yeah? Do you know magic? No. Then what happened? Okay, let us come to the complete conclusion later. So what happened now? The color of that red litmus paper changed into blue when? While dipping on sodium hydroxide. Okay. In the same way, everyone just dip both the blue and red litmus papers one by one into all these three test tubes and note down your observations. Okay, have you finished your work? Yes. Then, anyone please read your observation. Okay, where is Rahul? Yes, Rahul, proceed. Okay, while dipping blue litmus paper into the vinegar, the color changed into red. Am I right? Yes. Okay. Actually, vinegar, we all know what is vinegar and for what purpose we are using vinegar. Does anybody know whether vinegar is an acid or an alkali? Yes, very good. Vinegar is an acid. Which acid is present in vinegar? Yes, of course, very good. It is acetic acid. So vinegar is an acidic solution or vinegar is acidic in nature. So, as Rahul said, while dipping blue litmus paper into this vinegar solution, color of the litmus paper changed into red. And just modifying your conclusion or your observation that while dipping the blue litmus paper into an acid solution, which means vinegar is an acid. So while dipping in vinegar or while dipping in an acidic solution, color of that blue litmus paper has changed into red. Am I right? Yes. So an acid can change the color of blue litmus paper into red. Then what happened when a red litmus paper is dipped into the same vinegar solution? Nothing happened because already the litmus paper is in red color. So red changed into red means there is no change at all. Okay, you got me? Yes, very good, my kids. Then, in the case of sodium hydroxide solution, while dipping blue litmus paper into this sodium hydroxide solution, no color change has occurred as per your observation. But what happened when the red litmus paper is dipped in this solution? Yes, of course, the color changes from red to blue. So the red color of the litmus paper has changed into blue color. So which means sodium hydroxide, or in another word, alkali solutions. And alkali can change the color of red litmus paper into blue. And what are the changes occurred to both the litmus papers while they are dipped in the sodium chloride solution? Yes, of course, no color change has occurred for either of the blue litmus paper or the red litmus paper, which means sodium chloride has no effect in changing the color of these two litmus papers because we know that sodium chloride is a neutral solution. So, in acids or in acidic solutions, color of blue litmus paper has changed into red. Color of blue litmus paper has changed into red when while dissolving or dipped in acids or acidic solutions. And in basic solutions or in the alkali solutions, color of the red litmus paper has changed into blue. And in the case of salts or neutral solutions, no color change. no color change has occurred to either of these two litmus papers. So, by using a litmus paper, we can identify, yes, we can identify whether a given solution is acidic or basic in nature. So by using these two litmus paper, we can easily identify a given solution whether acidic or basic. Okay. So now let us think about that farmer. He told me that in order to reduce the acidity of his soil or his land, he uses slaked lime. Okay. So how he came to know that his soil is acidic in nature? Yes. By using these litmus papers, he can identify whether his soil is acidic in nature or basic in nature. So by utilizing or by using this litmus paper test, we can identify. But how he came to know that the acidic strength of his soil is much larger? He told me that in order to reduce the acidic nature, he used slaked lime. So he must knew that the acidic nature of his soil is very high. That's why he is trying to reduce the acidic nature. So by using this litmus paper test, we can't conclude or identify whether a solution is acidic or basic. But how we know whether the acidic character of that given solution is higher or lower or larger? Okay, so in order to know or knew whether a given solution is more acidic or less acidic, we have another technique. Before going to that, we have one more simple experiment to execute. Are you ready? Okay, you're all ready. But before entering into the next experiment, please stand up everyone. Just stand up. Okay, clap 3 times. 1, 2, 3. Once again, 1, 2, 3, and again once again, 1, 2, 3. That's my guys. Please take your seats. Okay, where is group number 5? Yes. Now you have been provided with a solution. Am I right? Okay, please write the name of that solution. Of course, the name of the solution is phenolphthalein. The name of that solution is phenolphthalein. So I have provided you another solution named phenolphthalein. Phenolphthalein. Okay. What is the color of this solution? No color? Okay, colorless. Then colorless. So phenolphthalein is colorless. Okay, it's alright. Now you have to drop 3 drops of that phenolphthalein into the vinegar solution. Drop 3 drops of phenolphthalein into that vinegar solution. So what happened? Nothing happened. Is there any color change? Nothing? Okay, no color change. Then add again 3 drops of phenolphthalein into that sodium chloride solution. Have you added? Yes, very good. What happened? Again nothing happened. No color change. What's this? Okay, no color change. Okay, we have one more solution left with us. What is that? Yes, of course, sodium hydroxide. Repeat the same procedure. Add 3 drops of phenolphthalein into that sodium hydroxide solution. Wow! Ha ha ha! Now the experiment has accomplished. So there is a color change in your solution. Okay, what was that change in color? So initially, what was the color of sodium hydroxide solution? No color. Okay, no color means colorless. And now what's the color? Pink? Yes, of course. So in sodium hydroxide solution, when we have added 3 drops of phenolphthalein solution, the color of the solution changes from colorless to pink color. Colorless to pink color. So which means both phenolphthalein has no color and initially sodium hydroxide too has no color. But when these two are came into contact with each other, they acquired pink color, which means phenolphthalein has pink color while reacting with an alkali, because sodium hydroxide is an alkali. Very good. So phenolphthalein has pink color along with an alkali, but phenolphthalein itself has no color. It is colorless, and along with an acid or along with a salt or a neutral solution too, phenolphthalein has no colors. So phenolphthalein has color, a pink color, only while combining with an alkali or a base. So that's the conclusion of our this experiment. So don't forget, phenolphthalein along with an acid or an salt has no color, but along with an alkali it has pink color. Okay, that's my child. Okay, now I have provided you all with some paper. Just go through that paper. What you can observe is, of course, that paper has different colors ranging from red to blue. It has many different colors. Okay, I have another paper. In that paper, I have some values. Let me write. The values range from 0 to 14. The value ranges from 0 to 14, and in between that 7 is marked. Okay, in between that 7 is marked. So the values are like this: 0, 7, 14. So 0 to 7 is one category and 7 to 14 is another category. This is the card that I have with myself, and you have a card, a paper with different colors. Can anyone tell me what is that paper, or for what purpose we make use of that paper? Okay, you don't know? Okay, it's not a problem because you don't know what actually it is. But I know. So, okay, I can tell you the name of that paper is pH paper. The name of that paper is pH paper. Yes. Litmus paper, we have 2 colors, blue and red. And here pH paper, we have many different colors. Okay? Yeah, okay. So pH, what is meant by this pH? Can anyone? Okay, so right. So pH means power of hydrogen. pH means power of hydrogen. So pH represents the power of hydrogen. Yes, I'm a powerful man. Just like that, a pH paper can indicate the power of hydrogen. Hydrogen means, what is hydrogen? H. Very good. H is hydrogen. But here, in our this topic, in our this discussion, hydrogen means H plus, that is the hydronium ion. We know that what is H plus. Okay. So power of hydrogen means the power of H plus. That means the concentration of H plus ions. the concentration of H plus ions. So that is what pH means. So pH scale. pH scale. You all knew what is a scale. What is meant by a scale and for what purpose we are using a scale. In the same manner, pH scale, the values of your scale range from 0 to 15 or 0 to 30 or maybe 0 to 100. Okay, that's your normal scale. But a pH scale has values range from 0 to 40. By using this pH scale and this pH paper, we can identify a given solution whether it is an acid or an alkali or a neutral one. Along with that, the range of its acidic nature or basic nature. By using a litmus paper, we only know whether the given solution is acidic or basic. But by using a pH paper, we can also know that what is the range of the acidic nature or the basic nature of that solution. If the pH value of a given solution, the pH value of a given solution is in between 0 to 7, is in between 0 to 7, the given solution is acidic in nature. The given solution is acidic in nature. And if the pH value is in between 7 to 14, in between 7 to 14, the solution is alkaline in nature. The solution is alkaline in nature. Then what is the remaining one? In between 0 to 7 and in between 7 to 14 means, yes, 7. So when the pH value is 7 itself, the solution is neutral 1. The solution is neutral 1. So by using this pH paper, we can calculate the pH value of any solution, and by using that pH value, we can confirm whether that given solution is acidic, basic or neutral 1. And I hope that now you all understood how that farmer came to know his field is more acidic in nature by using this pH paper test. By using that pH paper, we can accurately calculate the pH value of any solution, and by knowing that pH value, we can confirm whether a given solution is highly acidic or highly basic or lower in acidic nature or lower in basic nature or is a neutral one. So by using this pH concept, pH means power of hydrogen concept, we can understand about a given solution or a given compound. I have a chart with me for you. Here is our chart. Can anyone please read? Yes dear, go ahead. Yes, pH scale. pH scale represents the concentration of H plus ions in a solution. pH scale represents the concentration of H plus ions in a solution. For acids, pH value is less than 7. For acids, pH value is less than 7, and for bases, pH value is greater than 7. And for neutral solutions, pH value is equal to 7. For neutral solutions, pH value is equal to 7. So that's all for our today's class, and you have a follow-up activity. Collect as many as solutions available in your home and bring them tomorrow to the class. Take different types of solution. It may be a kerosene, a salt water, a muddy water, normal water, you are drinking normal drinking water, water from your pond, nearby pond, from your well, from your tap water, anything you can bring. Tomorrow we can calculate the pH value of all those solutions, and we can compare their acidic, basic or neutral character with one another. So you got me? Very good. So you have to collect as much as possible different solutions and bring them tomorrow to the class, and be cautious while collecting these solutions. Hope you're all ready for tomorrow's exploring experiment. So if you have any doubt, please ask me. Okay, so that's all for our today's class. Thank you.